If dot product is equal to 0, then the vectors A and B are said to be perpendicular. Vector A is perpendicular to vector B. Suppose if I, J, K are the unit vectors, then the dot product I dot I, J dot J and K dot K is always equal to 1. If A dot B is equal to 0, then the two vectors are said to be perpendicular to each other. Just multiply the coefficients of I cap, J cap and K cap and add it. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now in the previous class we have discussed regarding the addition and subtraction operations on vectors and finding the unit vectors and the problems based on that. Now in this session I am going to discuss regarding the very important concept, that is the product of two vectors. Matrix multiplication of matrix, the product of two matrices. Whereas in vectors we have product of two vectors as the dot product. The dot product, or it is also called as the scalar product. Scalar product of two vectors, or it is also called as dot product. The dot product of two vectors is denoted as A dot B. And this A dot B, the dot product is always a scalar quantity. This is a scalar quantity. A dot B is called the dot product. Now, suppose, let us consider the two vectors. Vector A is equal to A1i plus A2j plus A3k and vector B is equal to B1i plus B2j, B3k. A1i cap, A2j cap, A plus A3k cap and vector B is equal to B1i cap plus B2j cap plus B3k cap. Then the dot product of A and B is denoted as A dot B is equal to, just multiply the coefficients of I cap, J cap and K cap and add it. So that is A1 B1 plus A2 B2 plus A3 B3. A dot B is equal to A1 B1 plus coefficient of J cap is A2 B2 plus the coefficient of K cap is A3 B3. This is called the dot product. The scalar product of two vectors A dot B is equal to A1 B1 plus A2 B2 plus A3 B3. That is A dot B is always equal to A1 B1 plus A2 B2 plus A3 B3, the summation. So this can also be written as A dot B is equal to sigma I is equal to 1 to I is 1 to n, that is AI BI. Okay, so that is A1 B1 plus A2 B2 plus A3 B3. Suppose if the dot product is equal to 0, if A dot B is equal to 0, then the vector A is said to be perpendicular to vector B. Now what is the geometrical meaning of this dot product? The dot product A dot B is always equal to length of A into length of B into cosine of angle theta, where theta is the angle between the vectors and the value of theta lies between 0 less than or equal to theta less than or equal to pi. So A dot B is equal to length of A into length of B. At once, if you want the cosine of angle theta, if you want to find the angle of intersection between the two vectors, we are using the concept of the dot product, and cos theta is defined by cos theta is equal to A dot B divided by length of A into length of B. If dot product is equal to 0, then the vectors A and B are said to be perpendicular. Vector A is perpendicular to vector B. So that is, vector A is equal to A1 I cap plus A2 J cap plus A3 K cap and vector B is equal to B1 I plus B2 J and B3 K. Then the dot product is defined by A dot B is equal to length of A into length of B of cosine of angle theta. A dot B can also be written as A1 B1 plus A2 B2 plus A3 B3, that is sigma I is equal to 1 to n AI BI. Now, if you want to find the angle of intersection, cosine of angle theta, cos theta is equal to A dot B divided by length of A into length of B. This is very important formula. So to find the angle of intersection between the two vectors, or to find the cos theta, we are going to use the formula A dot B divided by length of A into length of B. Now I will represent it in a geometrical form. So this is, suppose if A is the vector in this direction, O is the position, O is the initial point. So vector OA is equal to vector A and vector OB is equal to vector B. Vector OA is equal to A vector and vector OB is equal to B vector. If theta is the angle between the vectors AOB, angle AOB is equal to theta. if theta is the angle between the vectors AOB, then the cos theta is given by angle between the vectors A and B is given by cosine of angle theta. Cos theta is equal to vector A dot B divided by length of A into length of B. Further, this dot product is commutative. So A dot B is equal to B dot A, and the distributive property A dot B plus C is also equal to A dot B plus A dot. These are the properties. This is commutative property, and the distributive property. So A dot B is also equal to B dot A. Dot product is commutative, whereas the distributive property is A dot B plus C is equal to A dot B plus A dot C. Now suppose if A dot B is equal to length of A into length of B, and A dot A, if A dot A can also be written as length A dot A is equal to length of A whole square. Suppose if I, J, K are the unit vectors, then the dot product I dot I, J dot J and K dot K is always equal to 1, whereas I dot J is also equal to J dot K, that is equal to K dot J is equal to 0. Let us see what is going to happen. So listen once again. If theta is the angle between the vectors, if theta is the angle between the vectors A and B, that is OA and OB, then the cosine of angle is given by the angle between the vectors is given by, since we know this, A dot B is also equal to A dot B is equal to length of A into length of B cos theta. So therefore cos theta is equal to A dot B divided by length of A into length of B. Hence, for a mutually perpendicular vectors I, J and K, for mutually perpendicular vectors, I dot I is equal to J dot J, that is also equal to K dot K is equal to 1. That is for mutually perpendicular unit vectors. These are all unit vector. 1 into 1 is equal to 1. J, unit vector, mutually perpendicular unit vector. For mutually perpendicular unit vector, I dot I is equal to J dot J, that is also equal to K dot K is equal to 1. Similarly, I dot J and J dot K and K dot J, K dot I is equal to 0. This is in case of a mutually perpendicular vectors. Hence, to find the angle of intersection between the vectors using the dot product, or it is also called as the scalar product, cos theta is equal to A dot B divided by length of A into length of B. Since the dot product is commutative, that is A dot B is also equal to B dot A, whereas the distributive property is A dot B plus C is also equal to A dot B plus A dot C. Okay. So these are the few properties regarding the dot product of the vectors. Now, knowing the dot product, one of the important application is to find the projection of the vector. So the projection of vectors, let us consider two vectors. Vector A, this is vector A, AB is the vector A and AC is equal to vector B. If theta is the angle between the vectors AB and AC, then the projection of vector AB on AC, that is the projection of vector A on vector B is given by, the projection of vector A on B is given by A dot B divided by length of B. Suppose the projection of the line AB on the vector AC is given by, that is the projection of A on vector B is given by A dot B is equal to, that is given by A dot B divided by length of B. Similarly, the projection of this vector B on A, projection of B on A is given by, the dot product is same, A dot B divided by the length of vector A. So therefore the projection of A on B vector is always equal to A dot B divided by the length of vector B. On B is length of B. Similarly, the projection of vector B on A is same. A dot B is same divided by length of A. These are very important concepts. So to find the projection, we are going to use the dot product. A dot B divided by length of B and A dot B divided by length of A will give the projection of the vector A on B or B on A. Okay. Hope you followed. This is very important concept. Now let us take problems on the projection and the dot product. Find the angle between the vectors A I plus j minus k, and b is equal to I minus j plus k. Now, to find the angle of intersection between the vectors, we know the formula for angle of intersection between the vector is cos theta is equal to a dot b divided by length of a into length of b. Now write down the formula. The angle between the vectors is angle between the vector a and vector b is cos theta is equal to a dot b divided by length of a into length of b. Okay. Now, what is a dot b? You know, a dot b is equal to the dot product. A dot b is equal to the coefficients of I, j and k cap must be added. So, coefficient of I is 1 and I is 1 plus coefficient of j here is 1 and the coefficient of j is minus 1 plus coefficient of k is minus 1. And in the second vector, the coefficient of k cap is 1. Simplify this. This is 1 plus into minus minus 1 plus into minus 1 is minus 1. Minus 1 plus 1 gets cancelled. This is minus 1. So therefore, a dot b is equal to minus 1. Now, find out the value of length of a and length of b. Magnitude of a and magnitude of b. Length of a is equal to square root of coefficient of I cap, j cap and k cap. That is, coefficient of I is 1 square is 1 plus j 1 square is 1 plus again minus 1 square is plus 1. This is equal to root 3. Similarly, the magnitude of the vector b is equal to length of vector b is equal to 1 square plus minus 1 square plus 1 square. Again, this is 1 plus 1 plus 1 is equal to root 3. That is, coefficient of I cap is 1, 1 square is 1. Minus 1 square is minus into minus plus 1. Again, plus 1 square is equal to plus 1. This is equal to root 3. Now, substitute here. Therefore, cos theta is equal to a dot b. What is a dot b? The dot product is minus 1 divided by length of a is root 3. Length of b is root 3. Cos theta is equal to minus 1 over root 3 into root 3 is root 9. Square of 9 is 3. So, therefore, the angle between the vectors is given by theta is equal to cos inverse of minus 1 by 3. This is how we are going to find the angle of intersection between the two vectors. Very important and very easiest. A dot b divided by length of a into length of b. Okay. Hope you followed this. Before going to the next problem, let me teach a few problems in the scalar product, that is the dot product. Let me take few examples. Let us take examples on dot product. Dot product. Suppose if a is equal to vector a is equal to 3i plus 2j plus 2k and vector b is equal to 2i plus j plus 3k. Now let us find out a dot b, then b dot a, and also find out 2a dot b. Let us find out the values of this. Now first one is a dot b. Let me take a dot b. A dot b is equal to the dot product of this a and b. The coefficients of I is 3 and 2. 3 into 2 plus the coefficient of j is 2 and here is 1. 2 into 1 plus the coefficient of k is 2 into 3. So this is 2 into 3. This is equal to 6 plus 2 plus 6. This is equal to 6 plus 6, 12 plus 2 is 14. A dot b is equal to 14. Now similarly find out the value of b dot a. B dot a is equal to b and a. First take b. 2 into 3. This is 2 into 3 plus coefficient of j is 1 into 2 plus 3 into 2. This is 6 plus 2 plus 6. Again this is equal to 14. So therefore what do you say? A dot b is also equal to b dot a. That means dot product is equal to commutative. Dot product of vectors is always a commutative product. Now let us come to the third one. So what is the third one? So to find the value of 2 times vector a dot b. So 2 times vector a dot b can also be written as 2a dot b. If you want, you can multiply the vector a with 2 and find out the dot product, or straight away you can write the dot product of two constant out, dot product of A dot B is 14. 14 into 2 is equal to 28. Let us take one more example. Suppose if you find the dot product of 2A dot 3B, 2A dot 3B. Now here this can be written as 2 into 3 is 6 times A dot B. This is 6 into, you know, A dot B. A dot B is equal to 14. 14 into 6 is 84. So this is equal to 84. Okay. This is how we are going to find the dot product. Okay. Now, suppose if you want to verify the distributive property, I can take one more example to verify the distributive property here. Suppose if A is equal to I plus 2j minus k and vector B is equal to 2i minus j plus 2k and vector C is equal to I plus 2j plus k. Now to verify that A dot B plus C is also equal to A dot B plus A dot C. That is the distributive law, distributive property. Now let us check whether it is verified or not. Now first find out B plus C, add vector B and C. Addition of vectors, that is 2i minus j plus 2k plus vector C. What is C? I plus 2j plus k. This is equal to 2i plus I is 3i, 2j minus j is plus j, 2k plus k is 3k. Now find out the LHS. What is the LHS? The left hand side is A dot B cross C. LHS is equal to A dot B cross C. What is A? A dot, that is 1 into B cross C is 3, B plus C is 3, plus coefficient of J is 2 into coefficient of J in B plus C is 1. The coefficient of K is minus 1 into coefficient of K is 3. So this is equal to 3 plus 2 minus 3. Minus 3 plus 3 gets cancelled. This is equal to 2. On the other hand, let us find out the value of, what is to find is A dot B first. A dot B, the dot product of A and B. A and B, 1 into 2, 1 into 2 plus 2 into minus 1 plus minus 1 into 2. Right. Now this can also be written as 1 into 2 is 2, minus 2, minus 2. Minus 2 minus 2 gets cancelled, you will get minus 2. Similarly, find out A dot C. A dot of C is equal to A. 1 into 1. 1 into 1 is 1. Again, 2 into 2 is 4. Again, minus 1 into 1 is minus 1. So, this is minus 1 plus 1 gets cancelled. You are going to get it as 4. Now, right hand side, what is RHS? RHS is equal to A dot B plus A dot C. A dot B plus A dot C. Now what is A dot B here? A dot B is equal to minus 2 plus A dot C is equal to 4. So minus 2 plus 4 is plus 2. So what is LHS? LHS is plus 2, RHS is also equal to plus 2. So therefore from 1 and 2 we can say that therefore LHS is equal to RHS. That is 2 is equal to 2. This property is satisfied. A dot B plus C is equal to A dot B plus A dot C. The distributive property is verified. So the dot product is commutative as well as distributive. Okay. Now let us take few more problems on finding the angle of intersection between the vectors. Now let us come to this problem. Find the angle between the two vectors A and B with magnitude. Here directly they have given the magnitude. Magnitude is 1 and 2 respectively, and then A dot B is also given. Actually what is given? Given the magnitude of vector A is 1 and the magnitude of vector B is equal to 2, and A dot B, the dot product is equal to 1. What is the angle between the vectors? Angle between the vectors A and B is cos theta is equal to vector A dot B divided by length of A into length of B. Now this is cos theta is equal to A dot B is 1 divided by length of A into length of B is 1 into 2. So this is equal to 1 by 2. Therefore, theta is equal to cos inverse of 1 by 2. So for what value of theta, cos becomes 1 by 2. This is equal to 60 degree. What is sin 60? Sin 60 root 3 by 2. Cos 60 is equal to 1 by 2. So this can be written as pi by 3 radians. So therefore, the angle between the vectors is given by theta is equal to pi by 3, or this can also be written in the form of the radians and the degrees. Pi by 3 radians are 60 degrees. 60 degrees the angle of intersection between the two vectors. See, straight away, this is also very important for 3 marks. Straight away they have given A dot B, length of A and length of B. What is given? Length of A is 1, length of B is 2, and A dot B is equal to 1. The angle of intersection between the vectors is given by cos theta is equal to A dot B divided by length of A into length of B. A dot B is equal to 1 divided by length of A is 1 and length of B is equal to 2. 1 into 2 is 2. Cos theta is equal to 1 by 2. Therefore, theta is equal to cos inverse of 1 by 2 means this is equal to pi by 3 radians. Pi by 3 radians, or it is also equal to 60 degrees. Okay. Now, let us come to the next type of problem. Hope you followed this. Now, here this is also an important problem. If A is equal to 5i minus j minus 3k and B is equal to I plus 3j minus 5k, show that the vectors A plus B and A minus B are perpendicular. So, this is also a very important problem indeed. So, as I told, if two vectors A and B are said to be perpendicular, if the dot product is equal to 0. If A dot B is equal to 0, then the two vectors are said to be perpendicular to each other. So, that is, if A dot B is equal to 0, then the vector A is perpendicular to vector B. Now, here what is given? Given that A plus B and A minus B. What is to verify? A plus B dot A minus B is equal to 0. Okay. Now, let us find out A plus B first. Now, the solution. First, find out A plus B vector. Vector A. What is vector A? 5i minus j minus 3k plus vector B. I plus 3j minus 5k. Now, simplify this. Therefore, vector A plus B can be written as 5i plus I is 6i plus 3j minus j is plus 2j minus 3k minus 5k is minus 8k. A plus B. Similarly, find out A minus B. Subtract. So, first is vector A is 5i minus j minus 3k minus of vector B is I cap plus 3j cap minus 5k cap. This is 5i cap minus j cap minus 3k cap, multiply by negative sign, minus I minus 3j minus into minus plus 5k cap. So 5i minus I is 4i, minus 3 minus 1 is minus 4j cap, 5 minus 3 is plus 2k cap. This is vector A minus vector B. Hope you followed this. A plus B and A minus B. Addition of vector and subtraction of vectors. This we have studied already in our previous classes. Add the corresponding vectors I, our corresponding coefficients of I, J and K, and subtract, you will get A plus B and A minus B. Now, find out the value of A plus B dot A minus B. Now, what is A plus B? A plus B is equal to 6i plus 2j minus 8k dot A minus B. A minus B is 4i minus 4j plus 2k. Now multiply the corresponding coefficients. That's all. 6 into 4 plus 2 into minus 4 plus minus 8 into 2. So, if this is equal to 0, then A plus B dot A minus B equal to 0 means A plus B is perpendicular to A minus B. So, what is the answer we want to get here is 0. Let us check. So, 6 4s are 24, 2 4s are 8 minus 8, 8 2s are 16. This is 24 minus 8 minus 16 is minus 24. 24 minus 24 is equal to 0. Since, what is the conclusion? Since A plus B dot A minus B is equal to 0, therefore vector A plus B is perpendicular to vector A minus B. That's it. So, therefore, vector A plus B is perpendicular to vector A minus B, because A plus B dot A minus B is always equal to 0 in this case. If this A plus B dot A minus B is equal to 0, then the vector A plus B is perpendicular to A minus B. This is very important problem indeed. So, usually you may expect this type of questions for 3 marks. See, I'll explain once again. What is given? A and B are given. Find out A plus B. A plus B, add addition of vectors. You will get 6i plus 2j minus 8k, and the A minus B, the difference. Just multiply this by negative sign. Minus I minus 3j plus 5k. 5i minus I is 4i. Minus 3 minus 1 is minus 4j. Minus 3 plus 5k is plus 2k. Now, find out A plus B dot A minus B. A plus B dot A minus B, the dot product. A plus B is 6i plus 2j minus 8k dot 4i minus 4j minus plus 2k. Then multiply the coefficients. 6 into 4 plus 2 into minus 4 plus minus 8 into 2. You will get 24 minus 8 minus 16. 24 minus 24 is equal to 0. So, A plus B dot A minus B is equal to 0. Therefore, the vector A plus B is perpendicular to A minus B. Okay, that's it. Now, let us come to the next problem. What is the next problem? Same. Find the angle between the vectors vector A and B with magnitude root 3 and 2 and A dot B. Just like the previous problem. What is given? Given that length of A, magnitude is nothing but length of A is equal to root 3, and similarly length of B is equal to 2, and A dot B dot product A dot B is equal to root 6. So, this is length of A. Length of A is root 3, length of B is 2, and A dot B is equal to 6. Angle of intersection between the vectors is, now, angle between the vector A and vector B is cos theta is equal to vector A dot B divided by length of A into length of B. What is A dot B? A dot B is root 6 divided by length of A. Length of A is root 3 and length of B is equal to 2. So, now this can be written as root 3 into root 2 divided by root 3 into 2. So, root 3 gets cancelled. What is remaining? Cos theta is equal to root 2 divided by, this is root 2 divided by 2. 2 can also be written as root 2 into root 2. This 2 can be written as root 2 into root 2. 1 root 2 gets cancelled. 1 by root 2. So, theta is equal to cos inverse of 1 by root 2. What is the value of theta for which cos inverse is 1 by root 2? Cos is 1 by root 2 is for 5 by 4, 45 degrees. So, this is equal to 5 by 4. So, therefore, theta is equal to pi by 4 or 45 degrees. The value of theta is equal to 45 degrees or pi by 4 radians. Very simple. Just like previous problem. They have straight away given the value of length of A, magnitude of A, magnitude of B and A dot B. Find out the cos theta. Cos theta is equal to A dot B divided by length of A into length of B. What is length of A? Length of A? Length of A is root 3, length of B is 2 and A dot B is equal to root 6. Let us divide this root, split this. Root 6 can also be written as root 3 into root 2. 3 into 2 is 6, root 6. So, root 3 gets cancelled in the numerator. You will have root 3 in the denominator 2. 2 can also be written as root 2 into root 2 and root 2 gets cancelled. 1 by root 2. Theta is equal to cos inverse 1 by root 2 means then the value of theta which satisfies cos inverse root 2 is pi by 4 degree, pi by 4 radians. So, theta is equal to pi by 4 radians or it is also equal to pi by 4 radians or it is also equal to 45 degrees. Okay. Now, let us come to the next problem. The projection of A 2i plus 3j plus 2k on the vectors B is equal to I plus 2j plus 3k plus k. This is also very important. As we discussed, the projection of A on B, the projection of vector A on vector B is vector A dot B divided by length of vector B. Similarly, the projection of vector B on vector A is A dot B vector divided by length of vector A. So this is the projection. That is what we have discussed. Now, what is the problem given? This is also a very important type problem. Find the projection of vector A 2i plus 3j plus 2k on the vector B I plus 2j plus k. Now, what is the formula for projection on A on B is A dot B divided by length of B. Let us find out A dot B first. A dot B is equal to, what is A dot B? Dot product of these two. 2i plus 3j plus 2k dot I plus 2j plus k. Now simplify this. 2 into 1 plus 3 into 2 plus 2 into 1. This is equal to 2 plus 6 plus 2. That's equal to 10. Now find out the length of vector B. Length of vector B is equal to square root of length of vector B. 1 square is 1 plus 2 square is 4 plus 1 square is 1, that is equal to root 6. So therefore the projection, what is projection of A and B? Therefore the projection of vector A on vector B is equal to, what is the formula? A dot B divided by length of vector B. So this is equal to A dot B. What is A dot B? 10 divided by length of B is equal to 6. So this is the projection. 10 divided by root 6. Hope you followed. This is very simple. So here, first find out A dot B. A is 2i plus 3j plus 2k dot I plus 2j plus k. So 2 into 1 plus 3 into 2 plus 2 into 1. 2 plus 6 plus 2 is 10. And the length of vector B, root of, magnitude of this is 1 square is 1 plus 2 square is 4 plus 1 square is 4, root 6. The projection of A on B is given by A dot B divided by length of B, that is equal to 10 divided by root 6. Suppose if you want to find the projection of B on A, suppose if this is required to find. Similarly, suppose if you want to find the projection of B on A, the projection of B on A is given by, B on A is A dot B divided by length of A. Now what is A dot B? You know A dot B. A dot B is equal to 10. This is 10 divided by, find out the length of vector A. What is vector A here? This is vector A. The magnitude of vector A is equal to square root of 2 square is 4 plus 3 square is 9 plus 2 square is 4. So this is equal to, what is this equal to? 4 plus 9 plus 4, 17. Okay. So 9 plus 4 is equal to 17. So this is equal to 10 by root 17. So the projection of A on B is 10 by root 6. The projection of B on A is 10 by root 17. This is how we are going to find the projection of vector A on B and B on A. This is also very important. So dot product of vector or scalar product of vectors, you are going to get one question. Either it may be on projection of vectors or finding the angle of intersection, that is cos theta. Cos theta is equal to A dot B divided by length of A into length of B, or the projection of A on B is vector A dot B divided by length of vector B, or projection of B on A vector is vector A dot B divided by length of vector A. Okay, this is how we are going to find the projection as well as the angle of intersection between the vectors. That is regarding today's session. Let us meet in the next session with a different concept and a few more problems on the angle of intersection and the projection. Thank you very much.